Welcome. In today's explainer, we're going to dive deep into the fundamental design patterns for building AI that can actually get stuff done. We're moving way beyond simple chatbots and into the really exciting world of AI agents. So this is really the core question, isn't it? For the longest time, AI has been fantastic at answering our questions. But how do we make that huge leap from a passive AI that just gives us information to an active AI that can perform tasks, solve problems, and achieve goals all on its own? And that leap is exactly where the AI agent comes in. You got to think of it as a truly autonomous system. See, it's not just a language model, it's the whole package. It can sense what's happening, it can make a decision, and this is the most important part. It takes action to hit a specific target. They are genuine problem solvers. You know, this quote from the source material just hits the nail on the head. A lot of us have heard of RAG, right? Retrieval Augmented Generation. It's great for giving a language model better info to answer a question. But an agent takes that a massive step forward. It doesn't just give you the answer, it uses the answer to book the flight or order the parts or run the analysis. It is literally the difference between knowing something and doing something. Okay, so here's our game plan. We're going to start with the absolute foundation and the most basic building block. Then, we'll explore different flow patterns to get agents working together. After that, we'll dig into how to make them even smarter. And finally, we'll look at the incredible collaborative future of AI. Think of it like we're climbing a ladder of complexity, one rung at a time. All right, so let's get started. We're at the very bottom of our ladder with the first and most fundamental piece of the puzzle, the single agent. So, a single agent is kind of like giving one person a really complex task and a tool, and then just trusting them to figure it all out. For instance, you could tell it, hey, plan a trip to San Francisco and use this search tool. The agent then has to rely completely on its own internal reasoning to figure out all the steps. You know, find flights, look up hotels, check the weather, all in one single continuous thought process. Now, understanding the trade-offs here is absolutely crucial. On the plus side, single agents are pretty simple to set up and they're great for straightforward tasks. But the moment things get even a little bit complex, they can become super unreliable. Because the AI is trying to juggle every single step at once, it's unpredictable and really hard to control. It can get lost pretty easily, which, of course, is why we need more advanced designs. So, how do we fix this problem of control and, predictability? Well, this is exactly where flow patterns come in. We stop trying to make one agent do everything, and instead we start creating a structured process for them to work together. Our first flow pattern is the sequential agent. And honestly, the best analogy for this is a factory assembly line. Each agent is a specialist at one particular station. It does its one job, and then it passes the result on to the next agent down the line. Let's use a real-world example. Let's say you want to find a late-night sushi place, and then you need to figure out how to get there. Okay, so first, a food-finding agent runs, it finds a great restaurant, and boom, its job is done. It then passes that restaurant's address to a transportation agent, which then figures out the fastest route. See, it's a clean, predictable, step-by-step flow. With this whole assembly line approach, you gain a massive amount of control and reliability. You know exactly what's going to happen and in what order. So what's the downside? Well, it's inflexible. If the tasks don't actually depend on each other, forcing them into a line like this can be really, really slow. And that brings us to the obvious question, right? What if some tasks don't need to happen in order? What if you need to do a whole bunch of things at once to save time? Well, this is exactly where the parallel agent pattern comes in and really shines. And right here, you can really see the stark contrast between these two patterns. Sequential is A, then B, perfect for tasks that depend on each other, where control is what you need. Parallel, on the other hand, runs A, B, and C all at the same time. This is perfect for independent tasks, like, say, finding a museum, a concert, and a restaurant for your trip. You don't need to do those in any particular order, so you can run them all at once to maximize your speed and efficiency. Okay, so we've given our agents structure with flow patterns, and we've given them speed. Now, let's give their intelligence a serious upgrade. Cognitive patterns are all about giving agents more human-like reasoning abilities. First up is the reflection pattern. And let me tell you, this is a total game changer. It gives an agent the ability to look at its own work, evaluate it, and then actually improve it. You're essentially teaching the AI to have a moment of self-awareness, to self-correct, just like a human would when they're revising a draft of an important email. The whole process is this simple but incredibly powerful loop. First, the agent generates an initial response. Then, and this is the magic part, it steps back and critiques that response. It basically asks itself, are there any mistakes here? Is this clear? Can I do better? And finally, based on that self-reflection, it refines its output. This little loop makes the final result so much more accurate and reliable. The other major cognitive upgrade is tool use. This pattern basically gives agents superpowers. It allows them to connect to external functions, APIs, and all kinds of data sources. So instead of being stuck with just their pre-trained knowledge, they can now look up real-time stop prices, book a dinner reservation, or access a private company database. They can actually interact with the real, live world. And this brings us to the very top of our ladder, where we combine everything we've talked about so far. Because the future isn't just one super smart agent, it's a whole team of them, all working together in what's called a multi-agent system. The multi-agent pattern is, well, it's exactly what it sounds like. A team of specialized agents all collaborating to solve a really complex problem. The best analogy is building a company. You don't just hire one person who's okay at everything. You hire a team of specialists, a finance expert, a marketer, an engineer, and you have a manager coordinate all their efforts. So how do these systems actually work in practice? Well, you have a central supervisor agent that acts like the project manager. It takes a big, messy problem and breaks it down into smaller, manageable tasks. Then it delegates each of those tasks to the right specialist agent for the job. These agents can work on their own or collaborate with each other. And finally, the supervisor gathers up all the individual results and synthesizes them into one single cohesive output. And the potential here is just enormous. This quote from AWS really captures it perfectly. We're talking about intelligent, multi-agent systems that can tackle incredibly complex challenges, coordinating their actions seamlessly. This isn't just a small, incremental improvement. It's a full-on paradigm shift that is going to fundamentally transform how we all approach work and innovation. So that leaves us with one final thought to take away. Now that you understand all the building blocks, from the simple, single agents all the way up to these collaborative teams, what's the big, complex problem that you would set your own team of AI specialists to solve? The possibilities are really just beginning to unfold.